Let's discuss CPU power consumption and TDP. The CPU is a huge consumer of power. That and the GPU use most of the power in a typical system. The CPU alone uses more power than a typical incandescent light bulb, and 10 times as much power as an LED light bulb. CPUs such as these will generally run around 1 volt. Now, CPU power is rated in watts. The Core i7-5820K that we've been discussing is rated at 140 watts, or 140 watt-hour. That is known as the thermal design power, or TDP rating. And multi-core CPUs, like the one we're talking about, they generally fall somewhere in that range, 100 to 150 watts for their maximum TDP. They don't have to be running at that maximum. That's going to be the max amount. Let's take a look at this with CPU-Z. Now, this is a great program to use. And if we take a look here, we see our Intel Core i7-5820K, and it tells us the max TDP, 140 watts. The voltage it's running at now, 1.015. It's hovering right about 1 volt. Okay, and that tells you lots of other information here. And so, for example, right now, our core speed is right at the max, 3600 megahertz. And that's because I have a lot of programs running and I'm actually recording this screen right now. So we're at the max multiplier, including the turbo boost for this system. Because, this is meant to be a maximum 3.3 gigahertz chip with a 10% boost up to 3600 or 3.6 gigahertz. But we can go past this and we can overclock, and so we're going to show this. Now, some motherboards do allow for overclocking, which enables the user to increase the overall speed of the CPU, and you do that by increasing the multiplier. You're increasing the base clock within the BIOS, within the UEFI, and that increases the internal clock speed of the CPU. So, for example, the X99-A motherboard that we're talking about here with the AV editor computer that I'm using, that can perform that basic overclocking we talked about, taking advantage of Intel's Turbo Boost technology, which goes from 3.3 to 3.6 gigahertz. Well, we're showing that now. We're seeing that. We're running at that max. CPUs don't always have to run at the max. They can run at an idle speed. In fact, this CPU's idle speed is 1200 megahertz. Then it steps up from there to higher amounts, 1866, 2400 megahertz. Right now, we're maxed because of all the stuff that's running on this system. But if you want to go beyond this, this is really built into the CPU. But if you want to go beyond this, for sustained overclocking, you have to modify that base clock. And so some motherboards, especially if you build your own system, they have the ability to increase the base clock. For example, from 100 megahertz to as high as, say, 250 or 300 megahertz, which then increases the CPU clock speed correspondingly. So, for example, we have our 3.3 gigahertz CPU, and, we can just refer to that as 3300 megahertz. If we were to take the base clock, and by default, the base clock speed is 100 megahertz. If we were to take that core base clock within the motherboard and increase that to, say, 125 megahertz, then this speed would then get increased to 4000 megahertz. So again, this is risky. This kind of overclocking method is risky. It increases the voltage, it creates more heat, and it could possibly cause damage to the system. So let's show that. Let's show how to overclock on this system now. I'm in the AV Editor Computer's BIOS right now. And so I've already rebooted the system and accessed the BIOS by pressing F2. And we can see our Core i7 5820K CPU here. By default, its maximum clock rate is 3.3 gigahertz. That's the maximum speed. So it shows that maximum speed that it can possibly run at now as 3300 megahertz. That's 3.3 gigahertz. So there's no overclocking going on aside from the built-in turbo boost 10% that you get, that burst rate, that boost, which can bring it up to 3.6 gigahertz. But that's built into the CPU. That's allowed by the manufacturer. But we can go beyond this into true overclocking, and we'll show how to do that here. We'll go to advanced mode, go to our AI tweaker, and we'll see here again, we're at 3300 megahertz. That's the max frequency by default. And our base clock is at 100 megahertz. So if we want to overclock the CPU, we have to overclock the base clock from 100 megahertz to higher. So first thing we have to do is the overclock tuner. We have to set that to manual. That's on this motherboard at least. Then we go to the CPU strap and set that, change it from auto, which is 100 megahertz, and change that to something higher. Now, I don't want to risk too much with this computer, and I'm only going to do this for a short period of time, but you can see the options we have here: 125 megahertz, 167 megahertz, or 250 megahertz, and you can modify that more in a lot of motherboards. 250 megahertz would be increasing the base clock by 2.5 times. Very risky. So I'm going to do the first option, 125 megahertz. Okay, and you can see that will change the base clock frequency down here. Now, it doesn't do that yet. You have to actually do a restart. So I'm going to do that now. I'll go to exit and save changes and reset. And OK. And come back once it's restarted. Now, you have to be ready for unforeseen results here. You can hear me pressing the F2 key probably, but you never know what could happen when you overclock. You can open up Pandora's box and it could be just a bag of tricks. So we're going to go into the BIOS here again. Okay, and success. It shows the speed now. The maximum speed we can do is 4000 megahertz instead of 3300 megahertz. Yes. So let's go. Now, there's also repercussions with this when it comes to the RAM. So that's a different thing altogether when it comes to the RAM overclocking. But for now, let's go back to our AI tweaker. And again, over here, we can see maximum frequency is now 4000 megahertz. And the base clock's at 125. Now, we can modify this further if we wish to, but we increase the risk every time we try to increase that number. But it does appear to be working, at least in the BIOS. Now, I did notice on the main screen that it was running a little bit hotter, about 41 Celsius, a little bit higher than before. So I have to watch out for the heat. You have to watch out for the increased voltage. So you got to be careful with all that. So I'm going to restart now and go into Windows and see if it actually works and check it out within CPU-Z. Okay, so we're back in here and we're in the OS. The OS seems to be running fine for now. The core voltage is up a little bit. And we do see our core speed, just like the BIOS was reporting, we're at 4000 megahertz. And that's really where this program gets it from. And we see the bus speed is at 125 megahertz. And that's what's happening here. Instead of a multiplier of 32 times 100 megahertz, this is a multiplier of 32 times 125 megahertz, bringing us up to 4 gigahertz. So if you're looking for that boost to do stuff, this is how you do it. But again, the risk equals the performance you might gain. So you could cause damage to your CPU, your motherboard, your RAM, even your hard drive and operating system. So you have to be real careful with that. Okay, so we've restarted. We're back in the BIOS here, and you can see that we are indeed going at 4000 megahertz now. And we also see that the RAM has been set lower automatically. It was 2400 megahertz. Now it's set automatically to 1667. And this is done automatically by the motherboard so that the memory and the CPU can communicate properly together. And so it's, in this case, it's kind of an inversely proportionate type of relationship where we've increased the CPU, but that means that the RAM has to go down. Now, increasing the RAM after this is possible, and this is a separate overclock. So if we go back to advanced and we go back to our AI tweaker and scroll down here to DRAM frequency, and we'll see the different options. Right now we're at 1666. Normally we're at 2400, but all those options have changed because we increased our processor from 100 megahertz to 125 megahertz. So we're not going to have 2400 megahertz for the RAM now. We could select other RAM frequencies here and increase all the way up to this now. Now, whether or not these are going to work there's going to be two things. One, if we set it too high, we could easily have failures. And two, if we don't set it to the right rate that'll work with the CPU, we could also have failures. So effectively, this memory is working the same way, but it's just that the base clock has been increased. So if we do increase this further, we do have to be careful with it. We'd only want to try a couple notches at first and see if that works and do some tests. And you really don't want to do this on any system that you have data on that you care about. So make sure you either back up that data or just don't even do it on a system with applications or data that you really want, just in case there's any types of issues. So this is where you would go to make those modifications for RAM. I'm going to leave ours as is, and we're going to set everything back to normal. Here's the thing. If you see that you are working with a system that has been overclocked and it's having all kinds of instability issues, or it's just crashing or shutting down automatically, it could be because of the overclock. So you want to make sure that you set these back to either auto or to the number that they require. So we're going to leave the DRAM as auto, and then we're going to change our base clock, which is called the CPU strap here. You could change it back to 100, but we're just going to change it back to auto. And you could change the overclock tuner to auto so that everything will go back to normal. Okay, and so we'll do that now, restart and head back into the BIOS. Okay, so I restarted the system and saved those changes and restarted the system, and you can see we're back at 3300, our regular speed for the CPU, and the RAM has gone back up to what is considered to be 2400 megahertz. And so if we look here, the base clock's back to 100 megahertz, the core voltage has gone down. Originally we were at 1.216 with the overclock. Now we're back at 1 volt. And it's amazing because just 0.2 volts or 0.25 volts increase means an increase in about 5 degrees, 4 to 5 degrees. So that's why you got to be really careful with the overclocking. You don't want to overheat your stuff. And that's just in the BIOS here. When we get into the operating system and start running the actual applications that do stuff and actually use the CPU, that's when the temperature is really going to skyrocket. So you'll see a lot more of an increase there. So that's why overclocking is something you have to really be careful with and test carefully. And if you see someone that's using it, especially in a company, you're definitely going to want to shut it down. And that's how you do so and set everything back to normal. Remember that most boards, their base clock is 100 megahertz. And to also check that DRAM frequency as well. Okay, so that was a lot of fun. Now, whether you overclock or not, the power used by the CPU and the amount of work that it does creates a lot of heat. So the need for efficient CPU cooling is paramount. Generally, what this boils down to is the use of an active heat sink, meaning one that has a powered fan attached to it. So here on the left, we have a tall tower-like heatsink, which attaches on top of the CPU. Here's the socket and harness, and here's the heatsink itself. And then a fan is attached to the side, which generally will push heat through the fins and tubes in the heatsink and then out through the exhaust fans of the case, and exhaust all that heat out. Now, whatever you use, you'll need to be applying thermal compound. also known as thermal paste or thermal jelly. And you do that to the CPU cap before you install this heatsink. And also any time that you remove the heatsink or remove or replace a CPU. One common example is Arctic Silver, and that's what I use most of the time. Now, in the past, long ago, we had passive heat sinks with no fan, but CPUs generate far too much heat nowadays. GPUs also, they have fans, most of the higher end video cards. However, you will see passive heat sinks without fans. They're commonly associated with the chipset on the motherboard, as well as RAM sticks and some M.2 drives. But getting back to that active fan heatsink solution, remember that that is the most common solution, but sometimes it's not enough. Sometimes this with a fan and case fans is not enough. And then a liquid cooling solution is required. However, that's only necessary on PCs with heavily taxed CPUs, and often ones that also contain a powerful GPU or more than one. So here we have something that connects right to the CPU, and then that goes out to this triple fan setup, and there's a lot of different options for liquid cooling. Okay, so know it. Every time you install or reinstall a CPU, you need to apply that thermal compound so that the heat transfer will work properly between the CPU cap and the heatsink and out through the computer. And you want to have the right type of cooling option, whether it's a fan with a heatsink or a liquid cooling system. And we'll talk more about cooling in an upcoming video.